Hello everyone. Today's video will talk about bases. A lot of people find bases difficult, but once we understand how they work, I'm sure you'll find them easy. So before we look at how to convert in bases and other things, let's just understand why first of all do we work with base 10. So imagine a man in prehistoric times counting sheep on his finger, right? Let's say he has 17 sheep. So he would say, okay, this is one sheep, this is two, this is three, this is 4, 5, 6, 7, 8, 9, and 10. So then in his head he says, okay, 1 unit done. So 10 is equal to 1 unit, right? And then he starts counting again from his little finger and he again does 1, 2, 3, 4, right? 5, 6, and 7. So 17 in his head looks like this 1 unit of a full hand and then 7 extra. That's what bases basically are. That whenever you move from right to left, you are increasing by a particular number. Let's understand this more by looking at how a man who would not count his thumbs count. So, if the same man had 17 sheep and he's not counting his thumbs, you'd say, okay, sheep 1, sheep 2, sheep 3, sheep 4. And since he's not counting his thumbs, he'll straight away move to 5, 6, 7, 8. So now for this person, 1 unit is actually just 8 sheep, right? So if he's now going to count 17, he will count 8 twice and left with 1 sheep extra. And the same 17 sheep will look like 21 to him. So see, the number of sheep 17 do not change, but how you write them, how you represent them. In base 10, they will look like 1 7. In base 8, they will look like 2 1. So the representation changes, right? Let's see. If I have a number like A, B, C, D in base x, what does this mean? It means that the number is ax cube plus bx square plus cx plus d. So whenever you move by right to left, right, you just keep multiplying by x, the value of that place, and then multiply it with a or b or c to find out the total value, right? Now the only constraint you have to be careful about is that any of these a, b, c, d can only be from 0 to x minus 1. So if you're working in base 10, your digits can only be 0 to 9. If you're working in base 8, your digits can only be 0 to 7. In binary, you have only two digits, 0 and 1. Binary is base 2, right? So now let's just convert between bases, and that should make everything far more clear. So let's do something easy. Let's say I have a number like 415. This is in base 6. How do I convert it to base 10? So this is easy, right? This is nothing but 4x square plus 1 into x, which is 6, that we'll substitute, and plus 5. So you'll get 4 into 36 plus 6 plus 5, which is 144 plus 6, which is 150, and this number is nothing but 155, right? So this is easy. Now let's say I have the current year, 2017, and I want to write this in base 8. Now how do we go about it? One way is to keep finding the remainder and keep dividing by 10. But I don't like that method. It's slightly counterintuitive, right? In base 10, we never write numbers from right to left. We always write them left to right. So the 2 comes first, right? Then the 0 comes, then the 1 comes, then the 7. So we'll do something similar here. So to find out how to write from left to right, we have to find the highest power of 8 that comes in 2017. So 4096 is 8 raised to 4 and 2017 is less than that, which means I have to start looking at 8 cube. So the first question, how many 8 cubes? What is 8 cube? 8 cube is 512. How many 8 cubes are contained in 2017? So approximately 3, right? So you remove 3 into 512, which is 1536 from 2017. And here you are left with 481. From 481, you need to remove powers of 8, and in this case you will remove 64. So how many 64s, right, can you remove from 481? So the answer is 7. 7 into 64, and you can remove 448. Now you are left with 33. So simple. How many 8s can you remove? You can remove 4 8s. Now you are just left with 1. That means you can remove 1 into 8 raised to 0, which is 1. So your number, you can now straight away write from left to right, is 3741. Right? So I hope this helped you understand basis. Let's see what kind of CAT questions come in this area.